Welcome to GPS STEM at UC Irvine's Life Beyond PhD seminar series. My name is Joanne. I'm the Program Director for Graduate Professional Success for STEM PhDs and postdocs here at UCI. Today, we're joined by Ted Yu, PhD, a UCI 2019 alumnus from the Material Science Department, and the brain behind Brews and Brains, which is now called Brain Public. He'll be sharing about how he went from a thesis in nuclear fuel reprocessing to working at a glucose monitoring startup, as well as his life as an unwitting purple squirrel. He'll cover topics including how to leverage your toolkit to get to your next career, managing imposter syndrome, and post-grad life anxiety. This was actually recorded with no video, so thanks for listening in.
Okay. Yeah, thank you for the introduction. As you said, my name is Ted. I graduated here. In fact, I used to work in ET in about 2019. I was in Wilson's lab. We were doing nuclear fuel recycling processes. So in and out of the reactor underneath Wilson Hall a few times and doing stuff like that. I did a lot of molecular dynamics. I was computational chemistry. So I was looking at, so that lab, we were doing nuclear fuel recycling processes, all the chemicals necessary to take uranium and plutonium out of nuclear fuel, which contains like basically the entire periodic table in some form, right? And how do you get rid of just a few things, especially when the chemistry is like really looking like each other? It's hard to do. So that was kind of what that lab was about. And I did a lot of molecular dynamics, studying just how those detergents, the surfactants, work to do the extraction. And of course, with any PhD, you're solving like a very, very small, tiny piece of that puzzle. And so that's what I did, and they let me graduate. And then what happened after that, Harinder, so your predecessor, he knew I was sitting around like, oh, you're applying for postdocs, right? Oh, you're not really doing anything. I know these guys can probably use like a temp. They have like some fancy microscope. They don't really know how to run it. Why don't you go help them with that? So you're like physicist, right? You can do that. I'm like, yeah, sure, I do that. 30 years later, here I still am with this thing. A vitro testing lab. So Metronome Health is a glucose monitoring company. In fact, one of the original founders of that place works like down the building, down the circle a little ways. I forget his name, another bio professor here. So what we're doing is what's called an optoenzymatic sensor. We're kind of distinguishing ourselves from the current glucose sensing in the market, which is like electrochemistry. We're using like optics and fluorescence. So what they had going on coming in is a gigantic fancy fluorescence microscope to do fluorescence lifetime imaging microscopy. So what that means is you have a tiny little sample and you're using your microscope, the stage moves around, you're looking at the fluorescence profile. Typically what people use it for is like they'll dye some sort of cell with a fluorescent dye, they'll map it out, and then you can kind of see, like you can image out structures, you can image out where all the fun chemistry might be going on depending on how you want to use your scope. And because we use the same fluorescence sort of technology in our sensor, it became very useful to have a microscope that could do that. So when I arrived, the microscope wasn't even in yet. I was like sitting around, okay, well, there's still a lot of physics you guys haven't figured out, so I'm just going to start doing that. And I just kept doing that over and over again. And then I, transferred from a guy who was just supposed to be here for like 3 months. And then now, like I said, I run all of the in vitro testing. I do a lot of the algorithms development for our company. There's a running joke, a dear friend of mine, a coworker who is now a dear friend of mine, he said, yeah, we put a problem in front of this guy 3 years ago and he's been distracted ever since. So that's kind of how that goes. So now you're wondering to yourself, what kind of overlap? Like what is it about my background that led to like being a good fit to glucose sensing? And there's basically zero. Nuclear fuel, there's nothing not dealing with anything radioactive with our sensor. It's going to go inside of a person. So I hope we're not doing that, right? What about all the computational chemistry? I've done zero computational chemistry since I graduated. But I guess what did work out for me is that I had a lot of tools that I kind of had from my undergrad all the way up to the end of my thesis that I just kind of accumulated. And I was like, okay, I can kind of see, I can use my science brain to just kind of, I'm going to put it this way, break down the Markov chain of things that go on in sensors. So, oh, hey, they made this thing, they made this change to it. I am seeing this thing downstream. And, you know, it's part of your training here as scientists is you're going to be able to see how all that works out. They did this, this happened in the test, it came out this way. You got to be able to piece together all that information. That's exactly why y'all are here, right? To learn how to do that. And essentially, by the time you're done with your thesis, you will have proved to the world that you've been able to do that at least once, probably a couple of times, right? That's kind of the idea. What does purple squirrel mean? I mentioned that in the profile. So if you go on Wikipedia, purple squirrel is kind of like this magical employee that just kind of comes in, knows everything about what you do, and you can just get to work. I don't like that definition. That's what people at the company call me, because it just doesn't capture how little I knew to begin with and just how like painful that journey actually was. Just the degree of uncertainty dealing with yeah, sure, I know fluorescence because I took an undergraduate physics class. I know if you throw light at something, you excite the electron to a state and then it comes back down. Obviously, that's not the entire story. There's a lot behind like how you can utilize that to, you know, use that as a glucose probe and do everything that we're doing, right? So fortunately, it did help to know the basics. But again, you have to, once your boots on the ground, the first thing I had to do was basically figure out, hey, what are we actually trying to do? What are you guys making? Can we just talk to people, start piecing together all of the physics of what's going on? But anyway, like, so I wanted to just kind of break this down into 3 parts here. Like the first part I want to talk about is like, okay, so like I said, that Markov chain of things, I'm just going to put it that way, is that you really do want to get really good at trying to figure that out. So one of the things I've took on, and like one of the bits of advice I might just give out really early, is whenever you go to, so number one, go to as many seminars as talks, different departments, anywhere as much as you can. Because the more just general knowledge you can start picking up, the more capacity that you'll have to start picking out like, hey, okay, so I saw this, is it that? And the capacity for your imagination to do that really is going to come from just the sum total of experiences, the total of all the knowledges, listening to people that have done weird things, new things, or, you know, just old things over and over again to have a lot of expertise around it. You want to start gleaning as much of that as you can, because then not only do you get better at being a scientist, but you're also going to understand like, hey, these are the techniques that are out there. These are the techniques, how that I can use them, how they work. You can start to see in whatever field you land in, you will start seeing like sorts of interesting connections to a lot of things. The more things you just know, so that's something definitely you want to do. And number 2, part of that is one of the things I'll suggest, always ask a question. When you're in these seminars about like these different sorts of like, oh, hey, this guy has this technique, or you take a class about a separationist technique and you go to a talk, someone presenting on their separationist technique. Might ask a question. And that way you prove to yourself, you've actually like listened to what they're saying, and you have to like make those neural connections on the fly to ask a smart question. Not only, yeah, again, like I said, more than just the proof, you're actually doing the work of trying to put the pieces together. So that's very important to do, I think. Yeah, that's the first part. Second thing is if you decide, so like I was talking with Vinny here, like you know, like some of you might be interested in just jumping into a new career because for whatever reason, like he was mentioning that like, hey, like one of the great things about science is just learning new stuff, right? That's probably why we're here. Some of you may have an idea of what you want to be. I've definitely met people like that, that that say, hey, I want to study this topic. And they go hard. They study everything they need to know, and they start to excel in that topic, and then they get a job in that topic. That happens. A lot of people in my lab ended up in national labs. Like, they went to like Oak Ridge, which does a lot of nuclear related stuff. Half the lab, which is actually funny enough. But if you're just interested in just doing new stuff, the other bit of advice I give about this would be that don't stress about what you think. Where I learned this, which poignantly, is I run a podcast. I used to. I can't in earnest say I run a podcast. We'll talk about that a little later. So a dear friend of mine, he is the history chair at Chatham University. I know him because I do Muay Thai. We punch each other in the face all the time. He just happens to be an instructor at our school. So he researches the history of fecal transmitted diseases, like beriberi, not just that, sorry. So he studies the transmission of very specific diseases. Beriberi is one of them. Beriberi is caused by a nutritional deficiency. He was looking at like, hey, the Japanese Navy had this problem. Other modern navies during World War II did not have this problem. Why? Turns out they were, it's a nutritional deficiency. But the other part of that puzzle is, well, why do they continue to have this nutritional deficiency, even though they know it is? There's a lot of sociology involved about how there was a cultural resistance to just making sure their sailors were fed properly. They had an idea of what that needs to look like. Well, anyway, the point is, so I had a chat with this guy. He was talking about one of the guys that he studied. So the landmark Japanese scientist who did a lot of the work getting rid of beriberi, not just beriberi, but also, I gotta take a step back, excuse me, scatterbrains. Okay. So there was a province, so before modern Japan became Japan, like pre-World War II, that kind of time, a lot of the agriculture was based off around what's called night soil. So you essentially take human waste, you compost it, and then you turn that into fertilizer. So the thing is, if you don't do that in a very particular way, you can transmit a lot of fecal diseases to humans, and it was a big problem back in the day. And then the scientist that my friend studied, he essentially ran what is a gigantic lab around just studying poop. Where I read a passage from one of his papers, or not his paper, like a autobiography. He was talking about, I have so many acres just dedicated to just vats of human poop from this province, another vat for this province, another vat for this province. And just by studying that composition, I just know what they were eating, what province it was from, what kind of Japanese people these people are, just because he studied all this stuff. And he was really proud of the fact that he had this essentially a state-of-the-art lab to study poop. But none of us are going to wake up one day saying, I want to study poop. That's what I want to do. Probably not what any of us imagined, but this guy was he talked about I built this lab from the ground up. I trained all the people how to do all this work. And he was very clearly very proud of it when he was writing it. So kind of the lesson for me there was okay, so right, like I said earlier, there are some people that are hey, I want to study high energy particle physics. In fact, I went to undergrad with the guy that said that, and he teaches in Santa Barbara now, high energy particle physics. And then there are the rest of us that are discover stuff, I don't really know what I want to do. And I think there's a lot of societal pressure telling us you should really know what you want to do. I'm really starting to disagree with that. So there's going to be a lot of anxiety, and I think it's born from that idea that you really should know what you want to do. But really, like I said, who wakes up one day and it's I want to study poop. You only get there by just kind of getting your boots in the ground in science, looking around you and then seeing the problems that need to be solved, right? And then that's really going to be where you're going to find your niche for something. That's how that goes. And I think that's really how most scientists are in their career at the end of the day, because like I said, you're not going to really know what problems there are to solve until you get in. You might have an idea, you might have read some papers about things that people do. I'm talking about the real nitty-gritty specifics that'll tell you, hey, I need to set up these experiments. I need to make these observations. And based off of that, okay, here's what I'm going to figure out my next steps. Only comes from just being in it. And where you are, where you land, where you're in it, don't stress out about it. You're probably going to be fine, as long as you have like the general tools. And that's going to bring me to kind of like the third point I want to make. It'll help you a lot to learn some general tools. There are many things that I found that are just applicable everywhere. One is statistics. You better know your stats. You better know them good. There's a good book called like 100 Statistical Tests or something like that. Get the author. And he breaks down, okay, here's this distribution, here's where it is, here's where it comes up, here's how you perform that analysis. Oh, what's a Pearson coefficient? Here's how you do that math. Here's what that number means. When people say, is your data normal? What does that really actually mean? Do you have a good sense of why the data that you see should be normal? It'll help to have a lot of statistics under your belt to do that. The other thing is learn Python. Oh, yeah, learn Python. If you certainly you can do a lot of the statistics using like Excel, or Minitab, or Jump, or anything like that. But every time I see someone do them, my heart skips a beat, and I'm like, oh, because there's two reasons for that, right? So number one, I found it I guess. So my undergraduate physics advisor, when I worked in his lab, his name was Dr. Small over at California. He actually made it a point of if you're doing this analysis for the very first time, you need to code it yourself, because that's how you're going to learn how it works. I want you to know the math. I want you to know the ins and outs of why it works. It's not going to be pretty, and it may not be as good as the packaged versions that you have, but the exercise there is really just know how it works, know when to use it. That's the idea. So having done that helped me out a lot. Being in school, it's a good opportunity to do that. You're here to learn things, right? So might as well learn something. It's highly encouraged to. There's tons of resources here at UCI. Even just walk down to that comp sci building next to engineering tower. Just pick out some nerds, be like, hey, I am certain they're always frothing at the mouth just to look at whatever you're doing and then see how they could be helpful with whatever data analysis tools and Python tools they have under their belt, and share it with you. I guarantee you that is how us nerds work. So please just ask someone if you don't know how to do any of this stuff. Or there's plenty of classes to do. And then the other part of learning Python specifically is that it's going to be much more powerful than just Excel. And the reason for that is once you have a good idea of the problem that you're working in, you'll probably have this analysis stack that you're going to want to come up with. And that sort of creative power is not going to come if you don't know how to use those tools to begin with. So when you have some sort of programming language under your belt, you can say, okay, so I know you do this for this analysis, then I, run up Pearson tests, and I know these things are right. So great. You start seeing that, then you can do it over and over again. You can put together a very rudimentary pipeline to help you run the analysis. So, yeah, very much suggested. So while you're here, pick up statistics. Make sure you know how to do statistics. And a bonus points would be, hey, if you learn how to do statistics on your own, as opposed to just using these packages, yeah, you can start automating a lot of stuff. Because it'll be better if you do it yourself. I found my experience, my old boss actually sitting here, like, if you rely on someone else to do it for you, they may not necessarily have the full understanding, and they're definitely not gonna think like you, right? So it may hurt more than help. Yeah, yes.
So when you're hiring now, as you see applications and resumes, what are you looking for? You're looking for in Python, you're looking for
Yeah, so
statistics?
there are two kinds of people that I typically hire for in my lab. People, well, number one, I need technicians, people that have enough of a science background to be able to say, hey, when I press this button, it does this. I know what that means. The thing I like to say to our applicants is that, hey, like, no one knows how our machine works. I know because I built it and I'm like only about 50% sure some days. So it's fine if you, it's unlikely that you're going to be able to find a place where everything you know, it's just not likely. You should expect to learn from that. So what I look for in just technicians is like, hey, can you show me in your resume, like, have you worked on a project? Have you worked on something to show that, hey, I had to learn something new. I saw that entire project in the end. The other people that I'm actually like hoping to be able to hire soon are like, you know, data scientists. For that one, I'd be like, hey, like, prove to me that you've done, again, the same thing, done a project where you look at data. Okay, now tell me, like, why did you do that? What did you see? Why did you do all that stuff? And then from there, really, I'm just looking for is, again, do you see the Markov chain of things? Yeah, that's typically what I like to see. Yeah, so that was probably a little bit more ramblier than I originally anticipated to be, but yeah, I work at a startup. I don't know much time to prepare it. So, you have any? Yeah,
I have a question.
yes, yes.
Sorry, do you have a question? Are you, is your company at the stage of like development of your product, or are you like already testing this out in humans? That's like a preface to my actual.
So, okay, so glucose sensing is weird in that there is a literal monkey in the middle of the development process, and that monkey is human. That's what they know. So part of the FDA recognizes there's so much difference between what you see on a bench and what you see in a human that like there's basically zero hope of you making a viable continuous glucose sensor on a bench. You can do very well. You can prove out the fundamental physics. That's what we do in my lab. But that's like 25% of the battle. So we do test in humans, but they're a lot like clinical trials.
Right. Okay. So my question is kind of something or like a key skill that I've kind of identified that I don't have for like the role that I want to apply for is really being able to like read and understand clinical papers, because a lot of what we do in academic science is basic research. So I don't know if there's like been any sources or any ways that you've been able to kind of like catch up as you've transitioned.
That's an interesting one. So I found that if you have access to someone who's been part of the clinical process, it's good to like buddy up and start like a small journal. Because I found clinical papers have a lot of jargon. And kind of the unfortunate thing about how humans learn is that when you're doing well, when you see that Markov chain of things, but there's that one term you don't understand, and it's going to just completely derail the entire process. That's just how it works. So if you have someone that can kind of tell you, hey, what does this mean? And what's the context, which is, I think, the bigger part of it, that's going to help you out a lot. So it helps to be able to buddy up with someone who's done that sort of work before. And barring that, hey, like you guys are still in school, I talked to one of the professors in the medical department or even some of the students. Like I said, we're all nerds here. We're like dying to like tell you about what we're doing, right? So ask somebody. Yeah. Yeah, that jargon's a steep hill though. I agree. Yes, saw that one first.
Okay, thank you. So I guess my question is, my perception of my friends who've gone on to industry that, you know, you get your foot in the door and then you jump to another position, another, and it seems that you've stayed in your position for quite a few years. Were there certain aspects that you recognized early on that made you stay, or how was that decision formed in terms of being recruited versus staying at your current position?
So I was definitely not recruited to stay. It was specifically labeled as a temp position. But I guess, I don't know, I wonder that sometimes too. Why am I still around? Because every day I stick around here, that's another like days worth of computational like chemistry knowledge is leaving my brain, right? But I guess, so there's a preface to your quick question is that, okay, like technically I have moved to different positions. It's a startup. My company is a startup, so positions are a nebulous idea anyway. So, I mean, yes, what am I doing? What I was doing when I landed here? Absolutely not. But to answer your specific question though, I don't know, like I just like solving problems. So I stick around and there's a very clear problem that needs to be solved here. And the other thing, no. So we were at a party that's partners here to support me today. We were at a party the other day and like, you know, you chit chat with folks and they're like, oh, what do you do? What do you do? Oh, I work in like diabetes something. They're like, oh my God, I hate what I have to deal with right now. My kids. I'm like, I get that a lot. I've heard that a lot. And every time I hear that, I think to myself, oh shit, maybe I should stay here. Like I can clearly like it seems like I can be helpful for this problem. And then honestly, if I'm honest, that's good enough for me. It seems like I can be helpful for this problem that we're dealing with. All right, cool. Let's get to work then. That's how I feel. Yeah. You got a question? Yes.
You mentioned it briefly. So you got this connection just through a friend to like join the startup?
Yeah, so the second guy to run GPS, well, what was called GPS Biomed back in the day, this program. Name is Harinder. I think he's still around UCI. I just knew him because I'm in and out of science. I was in and out of science communication during my time here.
Yeah.
And yeah, he just knew I was applying for postdocs. And he was like, yeah, it's a temp job, get some money while you're, don't just sit on your ass, right? It's probably not going to be healthy for you. And I was like, no, it's not. No, please let me do something. Yeah, that's all it was.
So for someone looking, I don't know if I'm looking for a startup or what, but if I were, do I just got to talk to friends and talk to y'all? Go to incubators, I don't know.
So there are
LinkedIn. It's not the same.
Yeah, I'm with you. I don't like that game. I'm not a fan. And I think that's also a contributor to why I'm staying where I am for as long as I am. If I'm being honest about myself, it certainly helps to just meet people for the sake of meeting people. If you go to incubators or these sorts of events around here, where scientists are going to naturally gather, like I said, you don't have to okay, so if you're wondering how do I, from these sorts of so I hear two things in your question. So where do I go, first of all? And once I'm there, how do I navigate those conversations to lead it to could you please hire me? To that kind of question.
It always feels like I don't feel so desperate, I've had combos with people and I'm like, oh, what do you do? And then I'm just like, are you hiring? And then there's this weight that's to that question,
No, I say it that way suspiciously for a reason. I understand what you mean. So certainly I would say when you go to these places where it's naturally congregate, I think so it's like a weird paradox. You want to there's a distinction to be made between being attached to something and making a commitment to something. They're not at all the same thing. So you can, we're getting more like real into Buddhist philosophy here now, like, but that's just the kind of person I am, so it's okay. So practically what that I think that means for you in your case is just talk about science, your science, just because you want to. And I bet you probably want to. You're a nerd, right? You're here. So I don't know if you're anything like every other PhD graduate I've met or people actively in it. That, I mean, we all like talking about our stuff. So, and not only that, be more interested in what they have to say than you have about yourself. Because you'll naturally find, keep going back to this idea, once you're good at identifying the Markov chain of things, you do it for someone else. You reflect that back to them. You have your own ideas about, well, what could be going on. I think that's when people really start to connect with you, is the idea. So, yeah, that'd be my advice. Listen to what they gotta say, ask, but what do they do? If you have something useful to say and how it relates back to your science, hey, even better.
I was just gonna add, so I've applied blindly to internships and I've gotten that. I've applied through friends who have recommended me, I've gotten that as well. And I've had my job given essentially to me by my predecessor because he knew me. And then my startup, I've made that job for myself. So there's so many different ways that you can go about it. And it's great that, you want to open all those doors if you possibly can. When you go to a networking event, you all kind of know they're all there for something. So just lean into it. My biggest takeaway, because I'm kind of shy, I do two things. I need a job. I need a job to do. That's why I always work front desk. But when I work front desk, I always get to say hi to everyone. When I say hi to everyone, everyone starts to remember me. Two, my only goal, I just want one business card. I want one good connection where I walk away thinking I feel like I made a friend there. And you're going to build that relationship over time. And then the big thing is that it doesn't come immediately. It's going to come as, hey, I have a job opening that I've heard. I know this person. I just remember them. They were great to talk to at a networking event. I'm going to ask if they know anyone. And you might just need a job at that time. So it's sort of an indirect way, but you're planting the steps for something future. And just know everyone's there for that same reason. You don't need to worry too much about it. But being there to share who you are as a person, what values you can bring, and the skill set they're looking for, what problems can you solve. So you did a good job of like that Markov event, tune into what they're looking for.
Yeah, and again, to reiterate on that point, I want to say this and get this point again, be more interested in their science than you are about yours. I'm not saying actually run your life that way, but for the sake of the conversation, that's where I want you to stand. Because again, like then you get to see where you fit in that chain, or you may potentially fit in that chain. That's I guess, because that kind of sells itself. If they see where you fit in that chain, hey, you go, right? That's, that's kind of the idea.
On that point, could you talk a little more about the product that you guys are building?
Yes,
I'd
so-
love to know more.
Yeah, sure. So we are making a continuous glucose monitor. So it's like a dermal implant, just goes like maybe a millimeter or so underneath the skin. And every 5 minutes, it'll tell you what your blood glucose reading is going to be. So it's a continuous glucose monitor. So the current ones on the market, you'll hear about the Dexcom or the one from Abbott. They have the Libre Freestyle. They use a electrochemical method of detecting glucose, which comes with some downsides. Drugs interfere with it. Like you take an Advil and now your blood glucose is going to be off by like 10-15% all of a sudden. But kind of using because we're not detecting the chemical byproduct of the reaction, which is how these things work. How all glucose assays work. In fact, you take glucose oxidase, it eats up the glucose, and then it produces hydrogen peroxide, and that's what you're measuring electrochemically most of the time. but we're essentially doing that, but using a fluorescence probe, which has the advantage of being super specific. Fluorescence probes, if you build them right, are very specific to just what you want to sense. And, you know, they also have the potential of being very, very accurate. Again, because of their specificity. It's probably about all I can say about our product. Yeah.
Awesome. And what are some skills that, I mean, you talked about some skills that you developed during your grad school or during just your career journey that helped you pretty much thrive in your job, or at least find your path from that temporary position to something like a role you liked. But what are some skills that you learned in your journey in the company as well that's got you?
Okay. Yeah, so I think this is the topic in and of itself. So I think the hardest lessons I've had to learn were not technical at all. They are not so I guess being a pretty good scientist is going to be a given once you're out of here, right? You should be a pretty good scientist by the time you have your PhD. That's kind of what that means, right? So it's the other stuff that is much harder. So how do you explain your ideas? How do you re-explain those same ideas again to different audiences? Because people don't think the same, people have their own problems to attend to, especially at a startup. Like, you know, we're continuously understaffed because it's just startup life, you know. So you say something to somebody, they're just not going to get it. They might have heard it, but it didn't like land. They didn't understand like, okay, this is the thing I have to deal with now, as opposed to, oh, I see how it falls in the Markov chain. And then so you'll find that number one, how do you speak the message? Number one, you gotta be able to identify, okay, there's a communication gap, number one. Number two, retool the message a little bit and then three, it may even just mean like taking them step by step, starting from the beginning, what you saw to just kind of explain it to them is the idea. So communication, I think, was the biggest technical hurdle. Because that's only something you'll learn by just having to have those conversations, unfortunately. I think while you're here, the best places to develop a lot of that stuff is to engage in science communication. Bree has a wonderful slew of classes to take. Definitely take those. Definitely take her, you know, scientific communication and the improv for scientists. So those two I think are very good. Side note, our Brews and Brains, if you've heard about it before, is coming back. I'm always looking for speakers. We'll be over at, so we're coming back at Spring Public now, where we're going to be doing like my podcast interviews, which is called This Grad Life. And what that's about is like I pluck grads or recent grads, and then they get to talk about how miserable they are because I know how miserable I was. You know, it's cathartic and it's also just human and it's also science, which is kind of neat. But yeah, any of those things, I'll be sure to put up the Brain Public information. But yeah, I would engage in science communication as much as you can. Very important. Very career development.
Thank you so much.
Yes.
Okay, so I'm gonna preface my main question again. In terms of like tiers, how high is scientist for like somebody who wants to be a scientist in industry? Is that like pretty much you're like a head honcho?
So startup, our titles are basically meaningless. I know they gave it to me because I've been around and they were just going to call me a regular scientist. That wouldn't make sense. That's pretty much exactly what they acknowledged to me, at least. So what does that mean in industry? It is a little weird. That being said, usually you'll see like senior scientists, but that could also mean just entry-level PhD scientist, but you're not like running anything. You're managing experiments for yourself, but the lab's not yours, or if that makes sense. I am not sure.
Okay, well, so then my main question is like, how much of a say or how much involvement do you have on like with like the business side of things at a startup?
The business side of things.
Position that
So if you're talking about the business side of things,
like the financials, whether your company is going to be alive in the next month or
so we have a CEO who really likes to keep things in the chest.
okay.
I've talked to other managers and say this is like unusually close to the chest, and I was like, either that means we're doing very poorly, or he just wants to, you know, this is probably doing way too much. Either he just wants to be like, hey, just keep doing your work, just keep doing your science and engineering. Oh, but by the way, if we really got this like today instead of next week would be really good. So maybe if you stay a little longer, you know, it's something I've just will call out their bullshit on, but you know, I think it's more related to that. But if you're talking about financial, what to say?
To piggyback off that question, in terms of project management, which I think can apply in different levels, how do you decide if you're gonna bring somebody in or collaborate with somebody or recruit them and do it in your own group? Like,
First of all, you're going to have to look at your resource constraints. So number one, how soon do you need those results? What kind of, do you need to buy new equipment or anything like that? How much time are you going to spend training that person up to do all that work for you? That's the sort of calculus I need to know first going in. And then second is, you know, you do the work, right? But again, as scientists, I expect all of us, we should be able to do whatever that means. But speaking to those three things, a lot of it is going to be, if you are in a position where you have to be a project manager and deal with other project managers, what I would suggest is to get really good at looking at things from their point of view. They will likely not have access to the complete information as someone who's a scientist with boots on the ground will have. So I do spend some amount of time to like explain to like, oh, okay, I see what you've, like, here's the goal that our CEO has set out for this, for us. Here's the project thing that we need to accomplish, you know, the series of check marks that we need to tick off. And then, of course, you're probably going to be the one that knows the experiments that need to run and the reports that need to be written. Talking about just dealing with the check marks and the people around the check marks. Yeah, it's just going to be, okay, when do you need this by? Really start digging in diplomatically, of course, really start kind of like asking around this question. And then a few times then directly ask like, okay, so what is this ask actually about? What do we need to accomplish? And if you're very clear for yourself, like, hey, what the company needs to do, you can always just tie it back to that. Now I've overridden a lot of requests that way, actually, because it turns out, you know, like I said, yeah, like not trying to put anyone down, it's just being boots on the ground every day. I have a very good idea of what it takes to get something specific done. So I listen for, hey, like, what do we actually need to do? What is kind of like, what do we need to actually accomplish here in terms of check marks? What do you want to see? And then from there, you can kind of retool that a little bit. And then, or you can just, you know, outright like, nah, I don't think that's why, that makes sense. Here's why, here's what we've done. And they'll be like, oh, okay, yeah, that makes sense. And then we'll just, you know, clear off a bunch of boxes that way. Yeah, that makes sense. Yes. You.
someone else can go. I can.
Okay, yeah.
No.
Yes.
I guess, what's your mental process for deciding how big a problem is and how many people get involved?
So I go back to fundamentally, what do we need to accomplish as a company? That's number one. So in our case, I know the specific research and development questions that need to be answered. Again, because by virtue of being asked to answer those questions every day for, 8 hours a day, typically more. So this actually, I think, this piggybacks off of your question very well. I'm going to ask a slightly different question too, to kind of add on to it. Like, how do you actually move up and start being able to throw some weight around? determining like what is actually important. So number one, yeah, so how do you determine what is important? Again, go back to what the company actually needs to do. Number two, ask from that context, think about, okay, what is this guy actually asking me? This team said they want this specific analysis done, or this project manager says he wants like, hey, we need to get this report written. What's the underlying anxiety point behind all of those things? You want to be able to get good at asking the questions that get at what that is. In fact, in my place, I've gotten like familiar enough with my folks that I just ask, well, okay, so what do you actually need to do? I'll even just ask that question directly. But when you're first starting off, you'll want to kind of ask around that question a few times, and then ask it directly after that. Soften them up a little bit, and you go in for, you know, the harder hitting question. Because and the part of the other thing is I found that like what I think needs to be done and what other people need to be done and what your CEO thinks needs to be done, they all need to jive, or else you're gonna have a very, very bad time. So again, I would just think about what are the anxiety points that they have to deal with, and then just kind of balance all that stuff. Yeah, and then from there, you'll get real good at like reading, like understanding people come into your cube with a specific face. And then they'll have like, you know, we'll have that walk. It's like, okay, I know what you need. I know who to talk to. And just start having those conversations. Yes, you and you, I think, right? Yes.
Yeah. What do you think were your two most marketable skills prior to getting this position, and what do you think your two most marketable skills are now in this position?
Probably the same thing. Python and statistics. For and coming out, Python and statistics.
Okay, how about non-technical skills?
Non-technical.
I
Non-technical.
think communication would be one that you would say.
Communication is going to be one. So the kind of identifying, diplomatically being able to ask, what is your point of anxiety? And I mean that as a very broad term. Like, so that could mean anything from like, hey, what do you see that needs to be get done from your point of view? Based off the information that you have that I may not have. What do you think needs to get done? Who's breathing down your back? You know, these are the sorts of things that you got. I think is part of the communication part. Be able to figure out what that is, and then figuring out how to navigate it, which is going to be the second part. That all comes with practice, unfortunately. And of course, science communication, crafting talks, that all helps a lot.
We'll do one more
One
question.
more? Yes.
Sorry if I missed it earlier, but what is your advice for overcoming imposter syndrome?
Oh.
You
Yeah,
have
I
that in
did
your
talk
talk
about it.
abstract.
So I did put that in my abstract. I should have talked about it. So, okay. So there came a point where, so early on in this place, I wasn't so good at the communication thing. I knew that there were things that we needed to get done, but I couldn't quite get over my frustration around that initial hump. That's the initial hump that I found. So like, okay, I gotta just not be frustrated so I can just have a reasonable conversation with somebody, because they're asking for this for a reason. They have an anxiety. Then wasn't very good at that. But I guess the first steps in my own training to be able to get that sort of skill was like there's one method that I've employed a few times to kill off a few projects that weren't getting anywhere. Like there were people involved that really wanted to see this little piece of the project through. Wasn't getting anywhere. And I was like, just decided we're just spinning our wheels. And the approach that I use there is the overwhelming evidence approach. So you present a lot of evidence, both in the literature and internal, that show like, hey, like we've tried this, not going to work. Also, here's the bit of literature and the like fundamental physics that this is not going to work. And I've killed off 2 projects that way. which I think would save us a lot of time, frankly. But I think but after doing that and after like asking like the right questions enough times to get to where we need to, there was a point where I was like reflecting and I thought to myself, like, there is no evidence for imposter syndrome at this point. I've clearly learned what I needed to learn. And I just, hey, if I don't take that message to heart, then I'm not a scientist, is what I told myself. Because you could I would assert by the time you're done here, there is no evidence for imposter syndrome anymore. That you're done. You've done the PhD, you've defended your thesis, you've done the work in the eyes of other accomplished scientists that, hey, you have what it takes to produce new knowledge. And in fact, yes, you have produced new knowledge, right? So at that point, by the time you're done, hell, probably even by the time after you've qualified, there should be no evidence supporting imposter syndrome. And I'll tell you what worked for me is, again, like I said, I took on the idea that, okay, there's no evidence for it. I know that's not how brains work. If I tell myself hey, I should just stop, that's never going to work, right? I knew all of that stuff going in, but I guess the specific words that I told myself is that, okay, if I don't believe the evidence, then I'm not a scientist. And I'm going to be a scientist. That is ultimately what broke me out of it.